So what are your numbers? Someone give me your numbers for number 7.
For the year or the cost?
Yeah, the year. So the years were
1975,
1975,
1985, 95, 2005, and 2015.
and then that's, so remember, time is always along the x-axis, always along the bottom. And the other one is $3, $4,
550, 550, 650, and
yeah, I was like, $8 for a movie in 2015? Seriously? But maybe it was in the Midwest, I don't know. It was not here, that's for sure. All right, so you're gonna draw it just like this, yeah? You put your years along the bottom, label it, years, and this is cost of movie ticket. So these can start wherever. That's fine, the x-axis. 1985, 1995. However, the y-axis, remember, the y-axis always has to start at 0. Otherwise it's a misleading graph. So y-axis always has to start at 0. What's the maximum my y gets to? $8. Yep. So go ahead and start in it. 0, 1, 2, 3, 4, 5, 6, 7, 8. And label a few of them at least. Oops. Oh, voice turned off. What's that? Useful. Over here. There we go. All right. Now I need to graph my points. So 1975 was $3. 1, 2, 3, about right there. 1985 was $4. 1995 was $5.50. 5.50. 2005 was $6.50. And 2015 was $8. And then just draw lines connecting them. Good. It's almost linear, not quite. Okay. Everybody on board? Done with this part? Yes? Okay. Let's talk about some other graphs. Okay, so there's misleading graphs. What's wrong with this graph? What's wrong with this graph? I would take a second to take a look at it.
It's the x-axis is nominal.
Yeah, so if you're Jared, would you be upset with your test grade looking at this?
Yes.
He's the middle guy. Yeah, you'd be upset. Should you be upset?
No.
No, Jared got a 96. Danielle got a 97. Right? So it's a misleading graph. What's wrong with it? The y-axis should always start at 0. When it doesn't, it's misleading. It makes differences seem huge. It makes it seem like Jared and Alexi totally failed the test when in fact they did fabulously, right? Here's another one, non-zero axis. All right, looks like Toyota Camry. I'd be worried if I was Toyota Camry, but they shouldn't because they're really like right up in there. So the right side is the correct graph, left side is the misleading graph. It used to be that only Fox News would do this. Now all the frickin' news companies are doing this. It's driving me crazy. It's just everyone's jumping on the bandwagon and saying, well, if they can do it, we can do it. And just, it's like they're like, well, it's not fake news, it's just misleading news. I don't know exactly, you know, but whatever. So be aware of that. This is a similar thing here, right? So you could draw a line that kind of goes through there. So those are almost the same. But because of the perspective they used, it made it look like 95 is a lot bigger. And then this is another one. Right, so how much bigger does the last one look than the smallest one?
Very big.
Like, how many times bigger would you say it might be?
Not enough.
So 8.
8, 15,
This is
30 times bigger maybe?
Oh, 70.
64.
Right, so here's the thing. It looks like it's maybe like 30 times bigger, but in fact, 18 to 74, it's less than 4 times larger. So what they're doing is they should have graphed it like this. Here's 18, 28,000, 51,000, 74,000. So they've taken one-dimensional data. It should be just the red lines. They've taken one-dimensional data and they've shown it in 3 dimensions to emphasize the difference. So they've made it look 60 times larger when in really, in fact, it's like 3.7 times larger. So this is, you're using multidimensional. So this is the last thing, these are the last things on your notes for chapter 2. Using multidimensional graphs instead of, for one-dimensional data. Okay, good. So now, we're going to talk a little bit. We're done with chapter 2 notes. Put them away. We're going to bust out our chapter 4 notes. Make sure you keep them. All right. Everybody ready? Here we go. Chapter 4 notes. Let's get a reader for this. How about Austin? Go ahead and read.
Probability can be defined as the chance of an event occurring. It can be used to quantify what the odds are that a specific event will occur. 75% chance of so, 1 in 158,324,156 and winning lottery. How chance of getting heads on a coin flip.
Right. Thank you. Thank you for reading and adapting to reading. I don't understand this. Oh, is that the deal? Yeah, and I even turned it off between classes so it wouldn't do this. And it still did it. Okay. So maybe it'll work. Okay. So yeah, but probability, you guys are familiar with that, right? So let's talk about some different things. Sample spaces and probability. A probability experiment is a chance process that leads to well-defined results called outcomes. For example, a probability experiment could be flipping a coin, or it could be flipping 2 coins. An outcome is the result of a single trial of a probability experiment. So it might be if the trial was flipping a coin, the outcome could be getting heads. If the experiment was flipping 2 coins, then a trial might be, an outcome might be heads, tails, right? Or tails, tails. Any of those could be an outcome. Is this still not working?
I think it's off. It showed that it's off.
Okay. Crazy. Okay. A sample space is a set of all possible outcomes of a probability experiment. For example, the experiment was tossing a coin. What's my sample space? What could happen if I toss a coin? I could get heads or tails, exactly. I roll a dice, if that's my experiment, what are all possible outcomes? What can I get?
1 through 6.
What? Yeah, 1, 2, 3, 4, 5, or 6. 1 through 6. If you answer a true/false question, what are your possibilities? True or false. And if I toss 2 coins, I could get heads, heads, heads then tails, tails and heads, which is different, and tails, tails. So the sample space is a set of all possible outcomes of a probability experiment. Here's an example, a rolling dice. Here's a set of all possible outcomes for that. So if I were to roll a 4 for the first dice, I could roll a 1, 2, 3, 4, 5, or 6 on the second one. Right? So the first one represents the first roll, the second number represents the second roll. So these are all the possibilities. Rolling 2 dice. We're going to look at a tree diagram. So we're going to use a tree diagram to find the sample space for the gender of children if we have 3 children. B for boy, G for girl. So a tree diagram is also known as a decision tree. So what's my first decision?
Boy or girl.
Boy or girl, right? I know I'm going to have 3 children, so it's not how many children I'm going to have. It's the first child, boy or girl. So I'm going to start from a trunk, from a point. Here's my trunk. Boy or girl. Now, if I pick a boy, what's my next decision? Boy or girl. So from the boy, from this point, my next choice can be boy or girl. If I had picked a girl first instead, my second decision would be again, boy or girl. Good? So it goes off of this G. The next branches go off of there. Or off of the B, it goes off of there. It's a tree. It goes off of the next bud. So now, they should be coming off of these guys here. So my third decision is going to be what? Boy or girl. And again, it goes off of the previous sort of branches. So then what's my sample space? It could be any one of these paths could be my tree, right? So it could be boy, then girl, then boy. That's one possible path. It could be girl, girl, girl. It could be girl, boy, boy. So here's my sample space. I'm going to follow along each possible path. How did I get right here? Well, this came from, if I follow back down, it came from boy, boy, boy. Boy, boy, boy. How did I get right here, this spot? Well, this came from boy, boy, girl. Everybody with me? This is my sample space. This next one came from boy, girl, boy. Boy, girl, boy. Boy, girl, girl. Next one came from girl, boy, boy. Girl, boy, girl. Girl, girl, boy. And girl, girl, girl. So this right here, and circled in purple, that's my sample space. The list of all possibilities of having 3 children. I mean, this is what could happen. It could be boy, 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 then girl, boy, then girl, then boy, and so forth. Okay. Here it is prettier. Yeah, that's the sample space. Everybody good? Okay, everybody move on? All right, so events. An event is a specific outcome or set of outcomes. Who's ever flown in a plane? The lady says, in the event of an emergency, what she means is, if the outcome of this flight is that we crash, or we might crash, right? That's what she's saying. It's an outcome. It's a specific outcome, not a good outcome. Luckily, that doesn't happen very often. So, probability of an event when all events are equally likely. Now, crashing in an airplane. Is that an equally likely event? Either you get in a plane, either I crash or I don't crash. Are they both 50-50? No, no one ever flies. There's a 50% chance of crashing. Do you guys understand what I'm saying?
Yes.
So that does not pertain to this because events are not equally likely. Everybody on board with what I'm saying?
Yes.
Okay, this is when events are equally likely. You take the number of ways that an event can occur and divide by the total number of possible outcomes. I like to shorten it by saying number of successes over number of outcomes. That's what I do. So, what's the probability of getting a 3 when I roll a dice? Okay, so when you roll a dice, what are the possibilities? You could get a what? A 1, 2, 3, 4, 5, 6. 6 possible outcomes. Probability of getting a 3. How many options are there for getting a 3?
It's 1/6.
Just one. 1 out of 6. Does that make sense?
Yeah.
1 3 out of 6 possibilities. And we write this like this. Probability that P, that's capital P, that means probability of. So it says probability of whatever's in parentheses. Probability of rolling a 3. Good? Or probability that X is 3. You can look at it that way. All right. What if I had a bag of 5 blue marbles, 3 red marbles, 4 green marbles? What's the probability of drawing a red marble? How many successes are there? 3. 3 red marbles. How many total possible marbles are there? 12. 5 plus 3 plus 4. So my probability of getting a 3 is, in red, is 3 out of 12. Good? You can leave it just like that for this class. I'm good with that because I'm more concerned that you understand the probabilities, not necessarily the cleaning up fractions part. If you want, you can write it as 1 out of 4. If you want, you can write it as 25%. I don't care. Okay? I'm good with any one of those. I don't care. All right, so here's a question. Remember, number of successes over number of outcomes. Family has 3 children. Find the probability that exactly 2, not at least 2, exactly 2 of the 3 children are girls. Here's our sample space. We just found this. Everyone take a second, take 30 seconds. Find the probability if family has exactly 2 girls.
So like in order.
No, just the probability. Number of successes over number of outcomes. Think of it that way. Okay, so what did you guys come up with?
50%.
Okay, so exactly 2. Does this one have exactly 2 girls? No. Does this one have exactly 2 girls? No. Does this one have exactly 2 girls? No. No. Does this one have exactly 2 girls? No. No. Does this one have exactly 2 girls?
Yeah.
No, it has 3 girls. Does this one have exactly 2 girls? Yes. Does this one? Yes. Does this one? So there are 3 successes out of how many possible outcomes? 8. 8. 3 out of 8. Good?
Yes.
Perfect. Good. So probability of having 2 girls, we might write it like this. Again, probability. Whenever you see a capital P in this class, it means probability, and then parentheses means of. Probability of 2 girls is 3/8. All right, so find the probability of each event with your neighbors. Go ahead, find them.
So that would be one. Because there's 6 times that die.
How many letters in the alphabet?
5 out of 26.
January through July.
So it's 3 out of 12. Five out of 7.
Let's check this out. The first one, rolling a die, the die is singular, the dice, and getting a 4. 1 out of 6. Selecting a letter of the alphabet and getting a vowel. One of those 3. These 5. So 5 successes out of 26. Selecting a month and getting a month begins with J. January, June, July. 3 out of 12. And then selecting the other week and getting a weekday. 5 weekdays out of 7. Good. All right, so have a great weekend. I will see you guys on Monday. Don't forget to start your homework.